Hello. So now we're going to teach you how to what to do after you come up with a significant ANOVA analysis with your data. So once I have a significant p-value, which is a p-value less than the alpha we decided to do, which is, and the other one we had the alpha is 0.05. So if this p-value is less than 0.05, we can continue to the next step. We say that, okay, between these three groups that I'm looking at, top of the hill, side of the hill, and bottom of the hill, are these data points, are they actually different from a different population of soil than the other ones? So when I look at this, there's this calculation we can do called LSD, or least squared difference. And I created a sheet that you can download off of Moodle that will look just like this. And you can take the output data points from this ANOVA single factor and put it into this LSD sheet and to figure out whether you have a significance. So we're going to look for within group. DF means degrees of freedom. MS means the mean squared. And these are calculations that come from here. Now, if you've taken a statistics class, these make more sense. But even without having a statistics class, the degrees of freedom are the total number of sample points minus 1. So we had 9 total sample points, so we have a total of 8 degrees of freedom. Between the groups, we had 3 different groups, so we have 3 minus 1 is 2 degrees of freedom, and then within groups it has to come out to 8, so that's 6. So that's how degrees of freedom is calculated. Now mean squared is sort of the difference between the mean and the data point. Those all added up squared. So the squares added up. So this is what the mean squared is. So we're going to use these two numbers to calculate the differences. So let's go back to the LS mean sheet for group A versus group B. So in here we would pick 2 different groups, and you want to compare. So say we're going to compare the top of the hill versus the side of the hill. So the degrees of freedom within group degrees of freedom are within group 6. So we go here 6, and then within group mean squared is 1.444, and put that there. Sample number for group A, each of our 3 groups had 3 data points, and the difference between groups A and B, so we have to go back here, and it's 14 minus 16, so that would be 2. The difference between 14 and 16, or 16 and 14 would be 2. And once all that comes into the least significant difference, for these to be significant, they'd have to be at least 2.4 points apart in their averages. So these are actually not significantly different. Now, if we look at 16 versus 18, we can go back, and that's also 2. But if we want to look at the top of the hill versus the bottom of the hill, 16 versus 21, so we can do 21.33 minus 16. And since I'm not going to calculate that off the top of my head, so I can just type it in here. And if you do anything where you're putting an equal sign before you just push enter, and we'll calculate that for you. Now this one is, yes, significant. So what that means here is that this is greater than this and this, but these two are statistically similar or not different from each other. So we might categorize this as A and then B, B. And that's how you calculate an LS